Okay, I have started recording. So this is the 12th tutorial session of this NPTEL course on functional mechanics. So what we'll be doing in this previous process, we'll just be giving some special topics in functional mechanics. Uh,
Yes, this should go inside.
sure.
Okay, so we will discuss, start.
Yeah. So I'll just share the notes that I have prepared
Yeah.
for period and I have not been able to fully done. That means we had reviewed these aspects, right,
Mhm.
of bond based. I think that we had did that one. I'm really sorry that I could not really complete all the lectures.
No worries. You
It,
don't need to, no,
okay.
you don't need to read that as so. It's, lectures is fine,
Okay.
but we can easily read and understand because
Okay.
SC is
Yeah.
very similar to SPH, so it won't take.
Uh-huh.
It's not. It's okay. That's what I'm saying. Don't worry.
Okay.
Yeah.
So last time what I had studied is how can you compute deformation gradient using aerodynamics? Since it
Okay.
invo- since it involves some discontinuous, I mean there is no continuity requirements of the function, right?
Correct. Because
So
these
we can
imagine that the function can be discontinuous. That's what I remember.
yeah yes. So what it was said that there are no tensorial strains. However, it's still possible to compute a deformation gradient f using integrals. So the integrals is again we use that weighting function, right? W. And
Yes.
as we recall that xi is our what do you call the bond parameter or the bond length. That and y is the what do you call are the coordinates of the any point in the deformed configuration, and the components are y1, y2, y3. And likewise, even for x, it's the same. X is that in the in X, it's that in the reference configuration again. So it's actually just trying to mimic that aspect, right? But in this framework.
This one.
Yeah. Yes.
Opening my iPad. Yeah. Good.
Yeah.
Did I tell you that I have installed one software?
No. Which
I, inst-
software it is?
I think I don't remember if it was here or in my server laptop.
I see. Hmm. I see.
It is in server. So I was able to install it, and I was able to run one case using Build Dynamics.
Okay. Okay. I see.
But however, that is too difficult to understand because it has C++ and kind of advanced C++. So I have no like don't have too
I
much
see. So
experience.
it's just like Paradigm, huh?
Kebana PD, Kebana PD.
Okay. Okay.
Because Kebana software I know how to install already. So those guys wrote Kebana Build Dynamics, Kebana Molecular Dynamics, Kebana that this they wrote so many. So it's very easy for me to just install it. So I was able to with PeriPy or PeriDyn it will take. I know how they have built it all that. So I was able to install
Mhm.
Capacity and I was able to run this problem where. But there are so many softwares in Build Dynamics. That's what I realized.
Yeah. Lots of actually.
We don't have to worry about that.
Yeah.
But my question is, um,
I think it's
so
the best to start with one particular software which we are most comfortable at.
uh, uh,
Yeah.
that is true, but not just that. One more thing I would like to ask is, how would you, because it is computational, it's not like we have to sit and do the coding like problems, right? Of course, we will
Mm.
read it. We need to we need to learn this in computational approach. That's what I mean to say. My
Mhm.
question to you is, where do you think we can start to code this? You already have it, that's okay. But if you don't code it per ourselves, as in वो existing लेके ही हमको code करना पड़ता है. It's not like we don't do it from
Yeah,
scratch. At
right,
least say
right.
that
That's
you have like I'll share my screen.
sure, sure, sure. Yeah, yeah. That would be nice. Yes.
Yeah. So like, hmm, shit. Yeah, here it is. What the hell is this? Yeah, this was. I lost it. Yeah, but anyways, that's not the point. What I
Mm.
want to show you is, or I will. Okay, okay. So this is SPH. Okay, I'll tell you SPH like how we will start with SPH usually, so that I make my question clear. If you can follow here, do you understand
Mm.
this equation by the way in the first place? If you see this,
Okay, so we
can you?
have the neighboring parts and then corresponding volume and then the weighting parts, right? Weighting part.
Correct. So you're trying to
Yeah.
find approximate the function at xi.
Yeah. Mm-hmm.
Okay. Now usually, so Professor Prabhu, took this course, SPH course in IIT Bombay. And how he would start is he will not go and directly solve. Uh,
Okay, so this
yeah.
is the same deformation gradient that we were talking about.
What? What?
This is the same expression for the deformation gradient that we just took a look. Okay, it's paid
Yeah.
and it's
It is, that's why.
mm,
That's why I'm like I'm looking at this. No, but my question is, so it's not a good idea to directly go and solve the big equations, like take full equations and
yeah,
solve the continuum
exactly.
equations.
Exactly.
What he does, I don't have a course right now. That's why I'm struggling to show you. But how we would go or approach about it is, downloading it again. Sorry. Okay, so what we will do is, so you tell me, just tell me this thing. Just a moment. See that you have a function.
Mm,
Okay, a sine function. Take a sine
mm,
function, and you
yeah.
can literally code a sine function, right? You can take from one dimension zero to two pi, and
Mm,
discretize it into like 100 points, and approximate. You can easily test this approximation. Do you understand what I mean by that?
yeah, yeah, yes,
So first we will approximate sine function. Okay, then we will
exactly.
approximate the derivative of the sine function. So the derivative of sine function is what cos, right? So we
Yeah,
know the
yeah, yeah.
exact function of derivative of sine, and we use the sine. So you use sine values, but you use the derivative of w.
Mm-hmm.
That's how you will find the derivative of sine, which is cos, and you will check how much accurate are these descriptions.
Yeah.
Okay, so so now we are confident about our w and gradient of w. Confident matlab we know that what we coded is right.
Mm-hmm.
Okay.
Exactly. Yes.
So
Yeah.
to test this function approximation and derivative approximation, we will do some simple problems like cos and sine approximations. This is what we do.
Mhm.
Why am I telling this is, so उसके बाद, so these are the real equations. Okay, so you have rho j, you like all this. So you have like divergence, right? And you have this double dot, right?
Right.
So you don't go and code this directly.
Yeah.
That's a bad idea.
Exactly. Mm. So
Okay,
this
you
is
first,
already inbuilt somewhere. Yes.
so first you do this, then you go and you'll do this. That's what how I
Mm-hmm.
have done it. PH. But my question to you or for us right now is so that I will go and do that simple thing, and next week we can meet prop. That's what I was thinking. Like we can discuss what we can do. Then,
Mm-hmm.
mm, but I don't see anything
Okay.
regarding query dynamics here. So I have read it actually. So it has something called states, which acts on vectors and gives you vectors. That's what I've seen, like rough idea.
Right.
But here I don't know how he's doing that. That part, or I don't know where we can start so that we can. Uh, so I see. So with the note which you shared, I've seen that, and I
Mm-hmm.
understand. We are directly writing uh, the approximations, the the deformation gradient approximation and everything, right?
Yeah. Yeah.
But before going there, do you think we can do anything simpler to,
I
like
see.
if you look at math, Perry Dynamics, MATLAB,
Mm-hmm.
there's so many. Look, very fast, BB3D. There are so many softwares. But this like chill. See, there's one more.
Geometry calculation.
So we can easily write one, bro. I'm telling you, very easy. He said
Exactly
open
that.
source, but I'm sure he didn't write for. So
Because
he wrote.
those are
Yeah, so this is good. So first is doing wave propagation. This is a problem, dude. Look, like how many shit files here. I know everything here. It's a
yeah.
big
Yeah.
issue. This is very difficult. We don't want to do this, but we'll do this. This is good. So what I've done is this guy published a paper, this PD MATLAB 2D. He's Pablo Selezan. Okay.
Mm-hmm.
So look here, P Selezan.
I see. Yeah. Yeah. Mm-hmm.
So this was part of a book, and I downloaded the book and just cut that part to understand if you can see anything regarding the software.
Yeah. Yeah. Yeah.
But I haven't
Okay. So
found
he
any.
uses the formulation from Sealing's paper. Okay. I see.
Correct.
Mm-hmm.
So, however, and this is in MATLAB. Also, there is this Perry Dynamics Python. Yeah, this PyPy. This is also really nice. This PyPy. This is, but now this guy said I'm discontinuing this, and he moved to somewhere else. That's what I remember.
Okay. Okay. Yeah.
But is this the one?
Yeah.
No, I think he moved to something else, bro. I haven't wrote it. I should have written. Or is this the one? I don't know. No, this is not. There's one more very nice software written in Python, which is what I want to show
Mm-hmm.
you. Yeah, this is the one BBTD. I think so.
Okay.
See,
Because
so
our
this
yeah. Yeah.
is uploaded yesterday. So this is in constant development, but this is not in development. Look, this is not. This is not. These are not. So we want to take
Yeah.
something which is trending also. This what. This is also nice.
Okay. I got you. Yes, yes.
But they're all very complicated. I don't want to, you know, go there and do it. Yeah, this one. This is what I want to show you. So if you look, this unnotched beam. So you have force applying here and here. and if you break it, it will, right?
Exactly, yes.
You see, and there's
Mm-hmm.
more fracture. You know anything about fractures? This stuff you read anywhere?
Yeah, somebody undergrad we had.
I
Okay.
so like I think he will have initial crack here already. You
Yes,
see that there's crack here, and you will apply the forces, and you will see how
exactly.
the crack would propagate. That's what more fracture is.
There are different types of tracks, right? K1, K2, I don't know which all modes they have.
Uh,
Okay,
and then
so
there's
this
this
was mixed
shear.
mode, yes. The sheer failure.
So there is this software, but this is I think written in MATLAB and C, which is we don't want to. So there are like these big softwares which. So if you so that's what. So what I want us to do is we'll take something, take the period dynamics thing, we'll take the fundamental thing, and go from there. So that why I'm saying this is introduction. Yeah. So it says brief introduction. He's rightly putting this, but it
Mm-hmm.
has so many components. No, like it has this
Yeah, he has not told
integral. How
about
would
that.
you test each of those properly so that we don't go wrong? Like once you start to write so much code, no, and if there is something wrong with the fundamental, and we will never be able to figure it out.
Exactly.
Um,
That's true.
that's what I think,
Mm-hmm.
but I could be wrong as well. But I think what we can start with this PD probably. It's like wave propagation. I think maybe this is the simplest benchmark. Do you
Yeah.
know how to use MATLAB by the way, Krishna?
Yeah.
Okay. Do you think you can run this example with this one?
Yes, I'll run try to let me just download it.
Okay, please. I
ORMS
will
3D
share
MATLAB
the
tutor.
screen now. I will share the screen. We can start with this now. We will discuss for 1 hour and stop. Yeah? Is that a good idea?
Sure.
Yeah.
Let
Yeah.
me just
Go ahead.
open my. So you
Stop
have
share.
could you please send that link to chat?
Yeah, sure. But you got the idea, right? What I'm trying to say.
Yeah. So
Taking the
first
fundamental.
we'll try to get our fundamentals with a clear first, right?
Probably maybe at some point I will tell you if you are interested. I can tell you how
Mm-hmm.
SPH works, like how we develop SPH,
Yeah.
and I will just record it so that it's easy for you for us to share to others and as well as.
Right. Right.
And I've stopped sharing
Okay.
now. No, stop sharing. Okay, stop sharing. How is the war going? Is it done? Is it they
Ah,
what
it,
is it?
it has
Decapitated?
acquired a new dimension. But any also the thing is I have stopped following. Look like
Why?
means today I just saw that there was some big miss.
No, no,
I don't
no,
know
no, 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 no,
who did what.
no. Don't. You don't like that, huh? Okay. Sure.
This one, huh?
Anything is fine. Don't you use Git?
Yeah, Git actually. Should I just clone it then? Because I thought that I'll.
Yeah, clone it. Yeah, that's how you should do it. And this is nice, man. How are you using terminal in Windows?
Yeah, this is Windows subsystem for Linux.
Oh, Windows subs. Okay, so you're running Linux in Windows.
Yeah, it's. I mean, that's what I had told you, right? Both
Okay, good, good. It's
Microsoft
very
they
similar.
stack
Yeah,
together. You see, you see
fantastic.
the
Yeah,
file structure.
yeah, it's great. It's like just like using Linux in Windows, man. It's very nice.
Yeah,
You
yeah,
don't
yeah.
have to. You don't have to. You can use both. You can use Windows and also
Yeah,
Ubuntu. Like it runs. It's excellent.
otherwise
Very,
it's very tough.
very nice. You can do anything now.
Yeah,
So say you say that you install MATLAB in Windows. Can you use that in Ubuntu?
MATLAB in Windows. Yeah.
How, my question
No,
is
then
how do you run code now? Because you're cloning it in Ubuntu.
yeah.
But
So I'll just use that file.
okay,
Let me see whether it works. But no, but it can be done. I'll just take it. So we need to clone this, huh?
correct. Just putting a
Uh,
speaker audio.
and then put here. It will come to this folder here. CSR 8000. This is the one, right? And we have to use this is the one, is it?
Yeah. So can you so he's saying if you look at the documentation, if you look at the
Yeah.
link, or he says how to
Okay,
run it.
so this one, readme.m.
Yeah.
Yeah. But the thing is, the new Microsoft File Explorer has everything built side by side.
That's excellent, man. Doing a good job on Microsoft. It's good.
Yeah.
Love it.
With this, what you're able to do is we can actually even translate MD file on the right hand side itself.
Yeah. Okay, let's read it and
MSP implementations provides an entry-level paradigm from technical and training for easily modifiable computational code for paradigm if researchers would like to adapt the code for a multitude. Okay, so run has to be done by passing input file to the top level function. I see. Okay. Okay, I see. Okay, so we have to do some mods. I see. So what I'll do is
do you have access to that paper, by the way? Because I don't have access.
I'll just try. Okay.
So the same guy is developing now Kevana PD. Like they are same from research group. And he wrote this in his PhD during PhD time. That's why.
Okay. Okay. Okay.
Okay, so first you will go to
Yeah,
the
I
folder.
can.
Then
Yes, I can. Yeah. So here it is.
wait, is this your file or his file? Wave one reader.
No, no. See, the thing is, I'm in that folder.
Okay,
If I double click it, it will open. It is the one.
wait. Now you're in that. Okay.
This I just do this.
You do proper MATLAB development. Okay.
No, no, no. These are some assignment problems. Okay, so let's have a
Okay.
look how to run it. Okay, so PD MATLAB wait for question. So it's running.
Oh, it runs, huh? It doesn't run
Yeah.
with. So I installed Scilab.
No, Scilab is, I think, a pathetic recreation of that. I
So
must tell you that
so
there are.
how should I run it with like how do you think I should run if I don't have MATLAB access?
Okay, what you do is, I mean, just install MATLAB and then I'll just give you my login credentials.
No, no, it's okay. No, I have access. I mean, I have MATLAB here. Of course,
Okay.
step in here, but I don't want to. I just thought like, can we do it in this?
VMAT
Okay.
is another alternative.
Okay, I'll tell you one good idea. Okay,
Yeah.
this is
Yes.
easily possible. Do you go to conferences, by the way?
Just one or two. One, I believe. One.
Okay, so this is a 2D paradigm code.
Hmm.
Okay, this can be easily written because I can see it running. No, we
Mhm.
can easily implement in PySPH. We both will do that.
Mhm.
Okay,
Mhm. Mhm.
we can easily write one paper, conference simple paper like open source dynamics code in PySPH, and you
Ah,
can
ah,
go and
ah.
present somewhere. But we will see. I think I can see that happening.
Yeah, I
Okay.
got you. Yes.
Okay. So what we will do this is, can we look at? Can you show me the way he's
So this
the
is the
way?
input file.
Okay.
Let's actually go through what is in the input file,
Yeah,
right?
that's what I want to see. Then we can understand what he's doing, right? Yeah.
Mhm.
The process.
So input deck for a web progressing with the initial displacement based on radial Gaussian distribution. The parameters are left
Maybe meter,
boundary, right?
maybe meters or something. Yeah. No. So what does this problem mean? So I want to see like, can we have any physical interpretation of the
Yeah, so
problem?
this is the problem for which the solution is this. It's like there is some source here, huh? And then it propagates radially outwards. Is
Okay.
it something like that? And that's how I'm interpreting. So
Okay. All right. No, and like I want to see like I will check that as well. Like uh, the process wave propagation. No.
yeah, yeah. And he has used a different time scheme known as velocity violated approach.
Yeah, that is okay. That is all typical.
So these are symplectic integrators, right?
Yeah. So this with this integrators,
Mm.
anything will work. That's first thing.
Yeah,
First thing I have to say.
right, right.
Anything will work. But
Mm.
if you but sometimes your schemes itself, as in your physics, okay, itself expects you to conserve energy. Like it says,
Exactly. So
it
this,
has no it says it has no dissipation.
right, right. Yeah.
Okay,
Hmm.
then your integrator should also be such that it doesn't like after some time steps. If you look at total energy, it should not dissipate.
Hmm.
Okay, sometimes you can write the integrator such that it is actually conserving the energy. But with the experience I have with all the
Hmm.
integrators, like I have seen so many integrators, it never
Hmm.
mattered. Never mattered. As far as I, and it is not at all big deal, like easy. OA, same cheese. Hai. Just that sometimes
Hmm.
with velocity wallet, I think you move the velocities first half time step. Have you
Exactly.
ever
That's
done this
what.
thing? I mean, I just want to ask how much experience you have with particle based techniques.
I know. All the
Just
best I have done is in what you call used Newmark beta, implemented Newmark beta method in my system.
I don't know. But anyways, I hope you're getting what I'm talking about. Else you just ask me, okay? So
Yeah.
is that what you have? You have these particles, no? You have all these points in the liquid dynamics, man. Velocity
Hmm.
volatility, I think you will move the velocities first. So you have these properties, right? Position, velocity, and everything. Density,
Hmm. Hmm.
what else? Deformation gradient, and everything. So first you move the velocities half time step. Then you
Hmm.
compute the all the accelerations using
Yeah.
that velocity. Then you move positions to the next time step.
Right.
That's what the velocity volatility is.
Velocity violet method is right.
And
Yeah.
Euler is like just move it once. I said both
Hmm.
cheese, and it's like it's okay. It's just same. But okay,
Hmm.
this is something interesting because why am I saying this is while we are writing our codes, next like by inspiration while we implement, I think
Hmm.
we should also remember that we want to attack several different type of integrators. So what we
Exactly.
can do is, so I will write some. Wait, do you want? I'll write it in this the notes you put.
Yeah, yeah. I think that is correct.
Good notes, good notes. साला ये क्यों नहीं दिख रहा था shared? Yeah. How to add a new page? Add a new page.
Yeah, there will be one page button.
Yeah, great. So yeah, I can write now.
Yes.
So if you can see the notes, okay. One
Okay.
thing So we are
Mhm.
doing with wave propagation.
Yeah.
We will first understand if it has dissipation.
Mhm.
And another physics.
Right.
Okay.
Right. Mhm.
And while we implement it in PySPH, okay, we will keep in mind we will deal with different integrators.
Yes.
We want to write it in such a way,
Mhm.
right? Such a way that we can easily add Verlet, Euler,
Mhm.
RK2. So we will write, okay. Then we can actually uh, test different problems and see how the integrators behave.
I see. Mhm.
Yeah, we can go back. Okay, so first is setting the time scheme.
Yes. So when the time span has been decided, we were blip and
I think so lost you all that, all right.
yes. Now we come to peridynamic model. So as you
Generalized
mentioned, right?
prototype.
Yeah. As you had mentioned that, I think this is good topic by topic now. Yeah. So now we can at the same time we'll just look at how constitutive models are formulated.
Okay.
Yeah.
You
And
know, you know
planar
what
model.
is you know what this generalized prototype microelastic brittle model is.
No.
Do you know
That's
that?
no. No idea.
But why is it? So my question is, why is he dealing with like brittle model in with there's no breakage or anything? Like I want to understand how is it coming in this wave propagation में? Why is he considering this constant model क्यों आ रहा है? Whenever you say wave propagation, मेरे दिमाग में वो Poisson equation याद आता है, right? Am I right? Is it a Poisson or no? It's actually wave, just
It's
a
a
simple wave
hyperbolic
equation.
equation. Hyperbolic
That
equation.
yeah, du by dt plus lambda times du by dx.
Yeah.
That equation comes to my mind. So this there's some questions I'm putting out there. I think we will answer it.
Mm-hmm.
Okay, then he has plane elasticity model.
Plane stress, yeah. Which for which yes, is because it's a 2D problem, so plane stress works fine.
Okay.
Though in the horizon he has set to 0.1.
Okay, the influence. Acha, acha, acha. Okay.
Yeah.
That's
And
interesting.
influence, yeah. The influence function order indicator is omega, it's constant influence function. And flag for bond breaking. So I think there won't be any bond breaking here, so that's why he has put 0.
So we have to check the other example then. Can you
Yeah,
open the
other example will be more, yeah, other will be more
track
interesting.
balancing one? Then if you can
Yeah.
see the variables.
So here it says that input deck for a crack bouncing on a P0 soda lime glass in plate. But this is the reference. Why do cracks from peridynamic investigation of dynamic brittle fracture?
That's what I downloaded, yeah.
Yeah.
No. I didn't download that, yeah, sorry.
So the domain boundaries are this number of nodes, grid participation, and here we have again
Sure.
same thing,
Okay, here
ZPMB,
complete.
and
Great.
here flag is 1.
Yeah, great. Awesome. Great. Great analysis. Okay.
And del is much is lesser actually, just
I think not
0.001.
any point. Discretion must be too high. That's why he took less horizon.
Okay. Actually, the thing is the domain is itself very small. You
Very
see
small.
that? Yeah.
So you
Unlike
see,
web
the
propagation, the
way we
domain is
do,
very large. Yeah, very large.
so correct. So the way we do this is in SPH. This is actually hard coding. This is not good way to code it.
Exactly. Yeah, yeah, yeah.
Okay. We will give that. We will give a flag like command and argument, like saying Itna spacing though. Then depending on the spacing between the points, we will set the horizon. And we should be able to
Okay.
change the horizon and we'll check okay कितना horizon से कितना change हो रहा है. Like in the
Right.
same
Right.
example, once we understand the problem, like क्या result आएगा, then we can change the
Mm-hmm.
del value and check how much influence it is. You know?
Yes. Yes. Right.
Okay. But I can see something. If it is 0.5, then the del is 0.001. I think it's doing by
Yeah.
100 or something.
No, it's actually 0.05.
So the del is how much?
Then is 0.001. It's
By
again, yeah, it's
50. By
no,
50 he's
yeah,
taking, no?
yes,
Am I
by
right?
50 was.
So in the
Yeah.
wave propagation problem,
So actually, the domain length is 10 centimeter cross. Uh, how much will it be? This is 4. So this 4
0.1.
centimeter cross 10. 4,
No, no, the
4
X
cross.
length is 0.1. So he's taking 0.001. If it's 0.1,
Yes, yes,
this is
yes.
0.001.
So 100 times.
Like by 100, huh? Okay.
Yeah.
So if you look at wave propagation, let me see the wave propagation. Input lines.
On wave propagation, is the otherwise. Wave propagation also here actually he has taken much smaller. So here is also, yeah, it's much smaller. So 5 divided by um,
Yeah, it's
0.1.
smaller. It's just 10. It's
Just
just
10
50,
years.
50, I think, right? Yeah.
Yeah, yeah.
50. Yeah, anyways, okay. That's good. That's something interesting to look. How, like we can know how much
Right.
horizontal. Yeah.
And then classical material properties, rho is one. These are
Which
just
one? Which one?
meaningless terms.
This maybe dummy problem, dude.
Yeah.
Yeah, there's no.
And
Yeah.
so mesh
Algorithm for computation
discretizing
of
is
neighbor areas. Okay.
algorithm for computation. So we need to know what FA algorithm is.
So one more point I can see here is maybe in the force equation, this t times that one.
Hmm.
I think we have. Do you have areas in that which the notes which you wrote? I remember. I think has. Let me see. No, I don't know why is computing areas in the first place. Oh, is that a 1D problem? The 1D problem we have
No,
areas,
no,
is it?
it's a 2D problem.
It's 2D. So 2D may you have
Yeah,
area. I think 3D may you
area.
have volumes. Is that how it
Yeah,
is?
yeah.
Okay.
Yeah, that's
We'll
true.
okay.
That's true. But
Then
then
he
comes
has,
body force density.
yeah, this is like that body force term. जो discussed में
Yeah,
है ना momentum equation.
exactly. So VVBW, X and Y component. What we see is it just this just boils down to 0 into X and 0 into Y. But the thing is then it just what does it make how does it make sense? Ultimately it's just 0, right?
I think no body force. If you look at the other problem, then you'll understand.
Okay.
Very
Yeah.
let me see that as well. Crank
Okay.
benching body force.
Um,
No, here he only considers zero. There's no body force here as well. There's no body force in the crank benching also. Zero, right? Here also.
No, no, no.
Yeah,
So we're here, right? So what is but why is it evaluated to zero?
it is zero in both the cases. So we'll just, I think
Okay.
maybe there's no gravity. That might
Okay.
be the case. Yeah.
Mhm. Okay. So we
Now
come to
he's
the.
using this tolerance, but is he doing any iterative stuff?
I think we'll have to figure out as we.
Yeah. Okay,
And
so
then
first
parameters.
the disturbance wave, the wave propagation disturbance comes. That's what
So
it is.
and then here's actually. Um, okay, these are the pulse samples, right? And then A is the magnitude of amplitude of radial Gaussian distribution. Sigma is the standard deviation. Mu is the radial distance. And these are the functions. Function distance from the pulse center.
No, they're just functions. I don't know what relevance significance is. Those have still.
Yeah, like these are just distance from the center, right? From the pulse center. U naught is the magnitude of initial displacement. V naught is the x component of initial displacement, and W naught is the
Okay.
okay. So these are just some initial conditions. I think we may need to take a look at some where they got the problem from.
Theory. Yes. Yes.
Yeah.
Yes.
Then the initial velocity functions are this. Then flag for plotting during time integration is 1. Frequency of plotting during this plot every 10 time steps beginning from the first one. Time
Okay.
step because okay. So here plot settings are this.
But where is he running the code? I don't understand. How to
So the
like
thing is yeah. So this is the main handler actually. So this is the handler. So it just
Oh, so you take that input file, then you read the values.
yes, yeah. So it just goes into input files and then run the input
Then
deck.
you should see the run function, huh? Now?
Yeah, and everything is here. Everything is in the source.
Okay.
This is the source actually. So should we
You have
look
main.
at main nodes? Main the exist grid file. Okay, grid wire, grid generate grid, no file mask, three nodes. So these are like it's they're just trying to generalize, right? So generalized code always looks very long.
Yeah.
Okay, so this settings and all of it. So which means then we need to. But which command did they follow?
But what is this run function there which is using? Is that I don't know, run input as
This one. Huh?
hmm It's
The thing
reading
is, what yeah,
reading
what
the
run no, what run does is it just executes. So when we had called right here, when we had called the function there, it just executed wave propagation.
hmm Oh, run runs it.
Exactly, yeah, yeah.
Then what is main do then? What is this? What?
Yeah, main is the this code here.
Oh, I think run will just set all the variables. Oh, run will
Right.
actually run will run that file, like
Yes,
MATLAB dot
yes.
the input
Right.
files will run, then all the variables are in the stack, like are there like
Exactly.
they're created, and those
Yes,
variables are used in the main function, and it will run the
exactly, yeah.
main is a
Right.
main function.
Mm-hmm. So now our next target is main because main contains all the results. So main actually it will first this is just check
You know,
check
there's
it with
one more easy way to look at this,
yeah.
to navigate the source code.
Uh,
What you can
yes.
do is, if you go, can you go to the terminal,
Okay.
change to the directory, change to MATLAB the PD directory, and that जहाँ पे तूने क्लोन
Okay.
किया.
So let's see. Okay, here it is. So,
Can you increase the font a little? Control X
okay.
plus, Control X plus, or Control Shift plus.
Control shift plus. Huh? Control shift. No, it's not running here.
Okay. Or you should do control express anyways, yeah. It's not there.
One palette. The thing is, settings. Okay. All content.
ठीक है चलता I
Yes.
can see it. Okay. So if you look at, if you do you have git now? You have git now.
Yeah, yeah, yeah.
So you
I
can
have Git
do
here.
log, enter. So you can see that, go down, just scroll, space. If you do space now, then it will go down.
Mm.
Okay. So wait. So you can see this initial commit.
Mhm.
Okay. So you can see that this log matlab they're adding so much code and they are logging them. Okay. The initial commit is at November 16th and it's done
Yes.
by William F. Godoy. You see the last
Yeah.
one, right? That it was
Mhm.
done November 15th. And after 4 days, so last year, okay,
Yeah.
4 days, Pablo Celestin committed. He said co-authored by Marco Passetto, Johan John, Jeremy Irageser, ऐसा कुछ. Okay.
Mhm.
Then you have Sam Reeve. Sam Reeve got in this November 22nd as well. He also came and also did some work.
Right. Mhm.
Now the point is, this is not so detailed. उतना details से नहीं commit किया इन लोगों ने कि like
Yeah.
the first version of working. Say that you have working. Say that अभी हमको because अभी बहुत code है ना. Like there's so many files. Like he added so much code.
Yeah.
The way to change, like you can actually change to certain commit.
Mhm.
You can go to the specific code history. Like say that
Yeah.
which time files are being added as you develop.
Mhm.
You can go to the specific, like you come if you come copy one of the commits like one two ऐसा कुछ है ना. If you copy that and if you do
Yeah.
git out that, if you paste that, then it will take you there to that code base and it is
Right.
much easier to navigate because हमको ज़्यादा files नहीं होते. जितना required files है उतना ही होता है. That's
Sure.
the beauty of Git.
Mhm.
But
Mhm.
anyways, so we know it when we write the paper. Yeah. Hmm.
Yeah.
Okay, can we go back or we can do? I
Yeah.
think we can stop. We can not stop here as in ideally, but so do you think it's a good idea to understand this thing by this? I mean, we will look at this code, 3D MATLAB, 2D.
Yeah, actually, it's a good idea to actually solve problems also.
Yeah.
Yeah. Basically, using a simple code, and then actually once we get the hang of how things are, then yeah,
Correct, correct.
then becomes. In fact, actually, editing MATLAB codes is far easier.
I agree.
Yeah.
You look like a good expert in this, so I think yeah.
Yeah, I just
And
tend to
I
use
understand as
MATLAB.
well, but it's just that I don't like some things with MATLAB. So
Hmm.
it's okay for like little things. You can always
Yeah,
rely on. And,
yeah.
but I think once we understand this, at least if you're able to do the crack branching and wave propagation, that will
Mm-hmm.
be first. You'll write. I think I can see that,
Yeah.
and this is a good starting point. There's a lot of code. I think I will also see like what I can remove and what I
Actually,
cannot.
the thing is, the required segment in the code is very less. Most of our just, beautification. Like,
Okay.
even if this were not there, we don't have created problem if we are just stuck to our own convention. Like, this is just whether the directory exists or not. Obviously, we are just having, we just have our directory. So this was just like check and balance. Now, if grid file exists, then it will do something. Otherwise, it will create it from grid here.
Yeah, yeah, I agree.
And then it otherwise if it doesn't, then it creates the grid. So it's as simple.
I think one more thing is if you look at the main file, it has so many function calls like this
Yeah,
one, this
because it all calls. So the first function it called is neighbor list.
one. Okay,
And the thing is, and then no, first it calls
grid generator. I think that
grid
he's
generator,
creating the point. I think
which is
just
this function.
exactly. I think no, no, you don't have to open that. I'll just tell you what he's doing. I think you can understand that from here. So he has grid generator. He has x0 xn. Matlab he has left point, right point, like bottom and top
Yeah.
points for the first four. And he has nx ny. Nx ny is number of discrete points in x, number of discrete
Yeah.
points in y. And
And
also, I
why?
don't know what PG. I don't know what PG is. But he's
Yeah. PG
returning.
is, let's just look. Actually, it was here somewhere. It's
Okay.
grid perturbation coefficient, which is 0.
Oh, yeah, yeah, yeah. Matlab, I think how much. Yeah, it actually depends. It's a really good point. It's like what he does
Yeah.
is I think he'll add some random. I think he definitely use a
Uh-huh.
random. He will use a
Mm.
random number and he will actually perturb the points. So if you go, let's go to the function and see grid generator. Then we
Should
will
we
write
just
it.
open?
Yeah. See, he says, see, you can see that. No, go up. It says left boundary, right boundary, lower boundary, top boundary, and yeah, grid perturbation 0 to 1. So it takes value from 0 to 1 and just perturbs the points, and it will return all the point values.
Mm-hmm.
That's what it does. Yeah, yeah, interesting, interesting. So yeah, I think this way we can easily okay. He's machine, then he's doing this computation. That computation. I think tomorrow morning, same time, I will just go through the code and just simplify all that stuff. Like what are the main points in the main file? Okay,
Okay.
then
Mm-hmm.
and also share you where from this wave propagation problem is lifted from, taken
Okay.
from the bad word taken from.
Mm-hmm.
Okay, then
Yeah.
I think that will give us a general idea of how to do this grid dynamics. Then we will read it like क्या है boss, ये क्या है, ये क्या है. Okay. So
Exactly.
you can
Mm-hmm.
also do what I mean. You can read some theory if you wish, or you can also investigate. Then we both will
Yeah.
be.
Think, from this code here, what we can do is we can understand how it's implemented.
Yeah, it is.
Like
Yes.
MATLAB is good to understand, and then we can always go to C++ or Python codes, which are looks tougher than
Yes,
MATLAB and
sir.
stuff.
Completely agree. Completely agree. Completely
Because
agree.
you see that, and he has actually created a code only for rectangular domains. Do you see that? Even it's hard coded in grid generator also.
There's a lot of code, man. Why did he write this much code, right? To grid generator. जरूरी
Yeah, and
नहीं.
then I think the main task would have been to determine
Oh,
the
computing areas also. It's computing areas, centroids.
exactly everything. Because
Hmm.
you see what all output it gives. This is the
Ah,
output.
I'm happy
Its
he wrote it
coordinate.
because now we are understanding. Okay, we are understanding that we should also know to compute areas and everything. Because I usually just get the points and leave it. I won't compute areas and everything.
Okay,
Okay.
okay. But the thing is, everything is returned here. You see that? X coordinates, Y coordinates,
Yeah.
and
Yeah.
area of coordinates in X direction, area of coordinates in Y direction. This is just like 1D array. Then mesh spacing in X,
Ah,
mesh spacing in Y. And here also, VV is the area of each
what is
cell
the difference
corresponding to each
between
node.
XX and X man?
XX is like a it's two-dimensional array.
But he says one day array of
Wait,
length and X
okay,
also X.
I'll just show you. I just need notepad for that. I'll just show you what it actually means.
Okay.
I think it should be some light. Does it have an absent light? That's fine.
Wait.
So it's like this. So if you want to write what you call XX, right? XX
Hmm.
is this. Say you have a domain
Okay.
name of length,
One.
say
One.
one,
One.
isn't it? And then you want discretized, discretized with 0.5 with spacing both sides,
Okay.
both X and Y. So domain is 1 cross 1,
Yeah.
1 cross 1. So now how will you write XX file? This actually MATLAB does it by itself, but the idea is something like this: 0, 0.5, isn't it? And then
Yeah.
1,
Okay.
0, 0.5, 1, 0. So this is XX file.
Got it.
And YY file, it's just the
So 0,
transpose
0,
of
0. 0.5, 0.5, 1, 1, 1.
exactly. Yeah.
Okay, so
That
what
is
but X is like X will ravel it, huh? Like 0.5, like it will make it one array. Is that what X is?
right.
It
Yeah.
ravels. Okay, okay.
Yeah. So then it gives us a 2D matrix. So
TK.
using for the
And
yeah, so this is what it is. Yeah.
no, no,
It
no.
actually is
Can you just scroll this? We'll just look at grid generator for now, just for 2 minutes. We'll see what all he's computing. Okay, so he's creating that points. That's okay.
perspective.
Okay.
And these are just and you again we must remember these are just checkpoints.
Value inputs. Okay,
To
fine.
check validity of inputs. So these are like unnecessary code.
Yeah, yeah.
If you know if you have written for yourself, then you would not need to do all this.
Actually.
The actual code starts here.
Yeah, so he's creating that whatever you wrote. Yeah.
Yes.
Then he still is creating
Then
here.
now we need
Create continuity matrix M and all nodes and all vertices X and Y. And remember says that
yes.
each row represents the nodes, each matrix M says that each row represents the nodes, four vertices. The four entities in each row correspond to the top left.
Hmm.
Okay, I don't know what this is, but anyways, okay.
They are just the standard quadratic this one, right? Element. But the thing is
Okay,
here we are not using finite elements, so it doesn't make sense.
that's what. It's
It's
only mesh.
just for connectivity purposes, so that we can compute
It's
which
not
will lie
complicated.
within the horizon. So it's like neighbors list for
Okay.
every element. Then you,
Ah, he's
then this
doing
is actually
time creating points, man. What the hell is this? Okay.
because he has written for a rectangular domain. I think this was easy to understand. But the thing is, if we write for a general arbitrary body, then this algorithm will be entirely very. I don't think we can understand it easily. So this is where it does accept.
That one,
And,
zero. Okay.
and
Oh,
this,
no. First he said that our mesh will be like this, and he's creating the mesh points first. Then I think he'll initialize all those values.
exactly. But then he fits everything. Yeah. Now you can perturb vertices in the interior of the domain.
Yeah,
Leave
yeah.
vertices on boundary and perturb.
Yeah, because boundaries should not perturb, no? Boundaries are boundaries.
Yeah.
It's like only
To
inside will
guarantee,
perturb.
yeah, to guarantee the cell remains convex.
Okay. It's all
And,
important, no? Like there is condition, like that is good, good, good.
yeah,
Great.
and then compute areas and center of cells. And then if p is greater than 0, do all this. Otherwise, we can just use the basic format. So we don't have to write complex code. No
And if
grid
it's
partition is,
perturbed, we have to be careful, no? Like if it's perturbed, it's not square
yeah,
anymore. Now it can't be expand by. If it's
yeah,
perturbed, then I think we have to.
that's why all those complex. Otherwise, if it's for rectangular, then it's
So
simple.
Italy
Everything
has
is
a
straightforward.
small code. Okay.
Yeah, it's a straightforward. So this small code. Now we can go back to the main.
Okay, that's done, man. That's
Yeah,
easy. Just creating some grid points. We don't do perturbation
right.
here anyways.
Yeah. And then comes this rectangular domain. Then is the generate neighbor list. So this is the neighbor list part. Right. It generates neighbor list and computes per bond quantity. The input is whatever we got from
Per
there.
bond quantities.
Yeah. Per bond quantity is also, so it does both the things. You
Yeah,
saw
this will
right?
be this could be a bit complicated, but anyways, yeah.
Yes. So what are computed per node? Influence function, neighbor area, reference bond
But
length, and coordinates of public.
pre-computed. Achha, I think these will be saved.
Yeah,
Okay,
yeah.
information, neighbor area, reference bound length, and coordinates and coefficient point. ठीक है, ठीक है, okay.
Okay, but what is the output?
I think we don't have
Okay,
to look at this like full code. I understood that he's computing that. Then what he's doing? He's
yeah.
go to
So so these are the output. Array of neighbor
number
numbers for all nodes. Array of instance function values for all. Array of
Oh,
neighbor areas. Array of reference lengths. Array of exponents.
do you understand that actually? So what he's
Yeah.
doing is he has a point, he has neighbors, and he has connections, and he's saving
Mhm.
the influence value of each bond. Like for each bond, he has influence values,
Yes,
and
yes.
he's taking that in IFNA.
Mhm.
He's saying that the influence value for each bond length. Yeah.
Yeah.
Okay. Let's go back now. How should we
Yeah.
should
Yeah. So this with this we have neighbor list and then it's best is computation solve this. Now we can so that I think main again. Then we have to
Okay.
create no fail mask. I don't know what this is.
I don't know what it is. Even I don't know what it
Yeah.
is. We can look later. Yeah.
Yeah. And then comes create free notches. Check if array of free notches coordinates is defined.
If array of free notches corners is defined, if exist. Okay.
I
Okay. I
believe
think
that
like in the
for
input file, we will
yeah,
have
crack
the free
propagation.
notch
Yeah.
coordinates. I think. Right.
Okay, we can see in the crack dancing, right? Yeah, here it is.
Yeah. 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 Oh, I think those points are like those are like
It's
cracked.
like initial crack. Initial cracks.
So I think you should see this. Like how is he doing this? What conditions is he putting? I am happy to see that.
Actually, it's a very, I think, very. Actually, the thing is, people from all these nationals, right? They write code in a very understandable format for
Yeah.
everyone. The three notes, if it exists. So for web propagation, this won't exist. So this won't be evaluated.
Dude, we should also write this in PySPH. I'm telling you,
Yes,
we should write exact detail because, and I want to say like I want others to say us like these ghosts wrote very nice. Like they wrote everything
yeah,
comment.
yeah,
I would love to. I love to have that comment from others. Like yeah,
yeah,
very
exactly.
well
That's
written.
true.
Very well written. Everything is very well written.
Now we come to main things, very dynamic constants.
Yeah. So he's doing. So
So
he's sending
PD
omega
bond
del
constant.
E. Oh, it's just a constant, man. I think it's
Yeah.
just some G value and E values. Yeah.
Okay,
So
okay.
this is
Could you
important. I
open,
think. Will be.
could you open that file list? Take a brief look.
Yeah, sure.
The output is micromodulus constant and
Constant.
critical step.
So now I will
Okay,
understand while
okay,
reading that
okay.
there is something
Critical
called
stretch is
micromodel.
the critical stretch is required to define the traction, right? So till this point, it's some value, then it becomes zero.
Break.
I think okay.
I
Yeah,
think
yeah.
now when we read the period dynamics, we understand there is something called micromodulus constant.
Exactly. Yeah. Here also he has discussed here that the GPMP is a generalization of the PMD by incorporating an influence factor. This was originally presented by Stilling and Esperi, a mesh-free method based on paradigmatic model of. It's presented on the role of okay. Input variable currently takes only GB. Okay, the input variable model currently only takes GBMP as valid input. Additional models can be added using the overall if statement. Okay, so we can. So here also there is a scope for enhancement of this code
Yeah.
because there is just one model implemented, GBMP. Additional models can be added, it says, using the overall if statement by adding an else if mod statement to specify conditions for each digit. As an example, if the model X is needed, one can extend the reference by this. So else if, and then we can. So there is scope for extending models to make it more complex, something like that. In this particular. Okay. So what it does is it just okay. You see check conditions, right? Del should be positive. The horizon should be positive. Then E should be positive. Then
Yes.
even Geo should be positive. And if star CMP model GBMP, then okay, you see, right? So plane strain. So it does all that constants plane strain, then that otherwise invalid, invalid. Okay.
Yeah.
So this we can close. Now we can come back to the original. Now we have impose initial conditions.
That's fine. You just set some.
Yeah,
Yeah.
yes. Then in compute internal force density and macroelastic energy density.
Initial internal force density and macro elastic energy density. Okay.
Because it's always force density that we are implementing this
Yes,
one,
because we're
right?
multiplying by the volume, no? So
Yeah,
remember
exactly.
that T
Yeah,
plus T times dV integral.
right.
Yeah, so that is force
That
density. Yeah, yeah.
is macroelastic energy density. So that they compute it here. So the output file. So these are the only inputs that were computed long back, right? In our I think grid generator. And then output here is X component of internal force density for all nodes, Y component, and then W is macroelastic energy density for all nodes. And yeah, the says same thing as mentioned, and then it's this much of code, and most of which is not worth it because it's just check balance again. So it's like a
Yes.
nice overview. Then we come to initial body force density, which was already zero, so nothing to
Zero.
worry about.
Yeah. Yeah.
Now we come to compute denominator of damage ratio. Now, if bond breaking is enabled, if bond breaking is not enabled, then do nothing.
Yeah.
Else, else if
Yeah.
it's there, then we have to use all that some summing, warming, some just simple. It's not complex code, and then otherwise flag BB should be 0 1. Just check and balance. So you see, this much of lines is just meaningless. But yeah, that is how it is. Then we come to time integration to create time vector, time step. And then we are
But
just
man,
looking
I
over
mean,
the time.
so he's, oh yeah, I think time integrated. We have to look. So before till the time integration Pele, he's doing
These are the
some,
right.
yeah, he's just doing some initialization, forced density computation, bond setting, bond sigma values, all that stuff. So I think time integration has important. We'll see that. Yeah.
Mhm.
Hold on.
The time integration is yeah, okay. So then it calls the time integration. So we take a look which all he has like implemented here.
Yeah. Can you open?
Yeah. So this is so time scheme is performance of time integration and displacement. So time currently only takes BV verblet as valid input.
Okay.
So additional time integration schemes can be added using the overall if statement. So yeah, this one can also be added.
He also wrote how to extend the code, man. He's fun, fantastic.
This can easily be extended actually. So all we
Yes.
have to do is we have to use this and copy this. The worklet will just copy and then make the additional
I love,
changes required.
I love Rocky to anything. Yeah. He wrote, see this for velocity wallet is first you move, see you use velocity wallet. Here you can see
Yeah.
that in the comment.
So
He's
yeah,
using
first.
acceleration at current time and in the next time also.
Hmm.
But this is equivalent to first move velocity to half time step. See, step
Yeah,
one.
yeah. Hmm.
Then you compute the
Then move
acceleration.
the place till there and then update velocity as well.
Exactly. I told you right. You move half, then. But in the first comment, like v of t equal to dt into at plus dt by 2. You see that right?
Hmm,
97 line.
hmm.
You might get
Yeah,
a
yeah.
question like, dude, how do I know acceleration is t plus dt, right? Because you didn't go there. If you go there, you will know. You are at time t. That's a question
Hmm.
everybody will get. But you write it as the next 100, 101, 102 line. That is possible to write, but not the
Okay. Right,
96.
right, right.
You get
Hmm.
the same values, the accuracy.
But then again, how was this obtained?
Yeah, you compute. So see, the point is, I think the way he does is first he moves v, then he moves rt also, but he computes a t plus dt using those one and two values. See, he can't. He should definitely say it is t plus dt, but he's using different values of velocity. You understand?
Hmm.
The acceleration is at t plus dt, but to compute that, I think he will not use velocity and position at those points. He will use velocity at t minus t plus dt by 2.
Okay, okay, exactly. Yeah.
Of course, it's not
Hmm.
possible. Like, it's not magic. It's not possible to
Exactly.
us. We have to be
Hmm.
confident. But while I was reading this, I'm like, should do I know nothing? Like nothing matter. Am I missing something? But no, it is not. It's not possible. It's obvious. You cannot predict future. Anyways, yeah, okay. So he's just doing typical time integration. But I'm just interested in how, like, he's doing any force computation and is he doing anything inside that? Can you go down a
Okay, yes.
little?
So velocity and then displacement and then update neighbor
Yes.
list if bond is breaking.
Ah,
Otherwise, if no bond breaks, then keep it as it is. Then
yeah,
you
here
just
he's,
complete
he's again computing the force. Then
force
he will use
density.
that again. Yeah, exactly.
Yeah. Complete body force and then complete velocity and then invalid time string. Otherwise, so there is a scope for extension here.
Yeah,
So,
yeah. This is good, good. I like this. Yeah.
and then we come to main again, and then this time integrated done. And it's all about when do we want this, because the steps to display on the screen, like what has been done, right? When we run the code.
Yeah.
So all this, yeah, all this.
So
Uh,
yeah, I got an idea. So you have points, you have bonds,
yeah.
okay, and you one important thing or where you can go wrong is to compute the force density. So you compute the force.
Mm-hmm.
First, you will set the mesh, set the bonds, set the epsilon values, set the horizon values. At every
Mm-hmm.
time step, you will compute the forces. Then you
Mm-hmm.
will move the because you have force, you will put density. Then you will move the bodies. Then you will check depending on the current bond length or some value. You will break the bonds
Mm-hmm.
and then just repeat this thing. That's it.
Yeah, yeah.
Easy, not difficult to implement in PySpace, but it will be fun. It will be real fun
Yeah.
to implement. Yeah,
And then we have all this dynamic plotting, and error, slack dynamic plotting.
very nice, very nice. I'm loving it. I'm loving it that how fast we are doing this. I think all the experience I had is actually adding up. Even though you don't have any experience, you are you're really catching up a lot with meshless techniques, which is fantastic. See, if
Mm.
you one thing is, I will teach you how to use this in PySpace, like how we will implement.
Okay.
No, and you can implement
Mhm.
anything in PySpace.
Okay, okay. Mhm.
I'm moving to some other software. That's a different thing entirely. But PySpace you can use for like everything. Like
That's it.
for your own problem, you might be interested in like there are computational research के लिए you can
Mhm.
use it as well. And I think I will implement this man. I think I'll be on it. So
Mhm. Yeah, and
so
then
yeah,
as the code ends, now we have final output.
yeah, yeah.
These are most of this beautification mostly, right? So
And it's
this is not
all
where we
what
should apply our minds on. Yeah. And it seems that in their log, I only most of the time I just see beautification log.
correct. Is
The
it?
adding tolerance to color limits
Okay.
for
Reverse class
empty.
function is it's nothing about the code like I
Yeah.
implemented for density वैसा कुछ नहीं है. It's not about the main algorithm. It's more about the
Yeah,
beautifications.
yeah, that's what I say. So just at the last, they have some fixed condition for it critical. I think they just uploaded multiple files and then just added some commit.
Correct.
So I think that used to do.
So do you
So,
know this git log thing before, by the way?
yeah, yeah, yeah.
Then that's good. Then
Git.
you
The
know
thing
git,
is,
no?
I'm aware of Git, but I have used also, but I don't use it very frequently.
You will use it. You will use git from now.
Yeah, yeah,
Definitely.
yeah,
Okay. And then
yeah.
by once you start working, no, then you will once you start working, you will understand the importance. Then you can choose like by we use
Exactly.
it. Then you can
Mm-hmm.
always use it or not use it.
Mm-hmm. Right,
But
right. Yeah.
no, because I used Git, no, all my research,
Ah,
I won't think like ये हार्ड डिस्क चले जाता है, वो चले जाता है, ये रिजल्ट्स चले
ah.
जाते हैं. I won't. I just do my research.
Mm-hmm.
And few days ago, I took a folder or took a research which was 6 years back. मैंने उसको रुका दिया था. उसको मैंने वापस लाके उसको redid it. So
I
it will
see.
all
Huh.
be that I remember like okay I did this, I did this, I did this, I did this. मैं यहाँ stuck हूँ. So all
Mm-hmm.
that you can easily keep track. So
Exactly.
but
Yeah.
anyways, we will see. Up to you to use it or not. But anyways, yeah.
Mm-hmm.
Great. Awesome.
Yeah,
Okay,
so,
so you just put an agenda so that I will work because what I'm doing is I'm doing all paradigms, man, because I don't have anything specific, so I'm not doing
right.
it properly. What do you think we should do for the next meeting? Or do you think it's a good idea to do? Because now what we have done is in our process we have looked at paradigms basics like क्या होता है, equations क्या होता है,
Yeah.
displacement क्या होता है, which is we have done. Then we have looked at softwares. क्या क्या
Mm-hmm.
software? Usme we have taken this one,
Yeah, yeah.
and we have
Yes.
looked at it, like we understood the algorithm now. Okay, which is
Mm-hmm.
going per plan. So next, what we can do, you tell me now. Like our first goal is to write a simple paper in PySpace. I don't like to write a PySpace, but I'm doing it for now. Okay, I will write
Yeah.
or you will write. One of us we can write. Like, we both learn that actually. So my
Mm-hmm.
first goal is to write simple Python में pair dynamics. Okay,
Exactly. Yeah. Mm-hmm.
already written softwares है. Okay, but we are doing it for more understanding, like because
Right.
when
So
time
that's
will go on,
that's
we'll
all.
have these
Yeah.
new models, like वो model होता है, ये model होता है. I think we'll stop
Mm-hmm.
sharing, no? We'll stop sharing. I think now. We'll just
Sure,
stop.
sure. Okay. Okay, I'll just share it. Mhm. Yeah.
Yeah.
I also
So,
stopped recording just for the sake. Yeah. Okay.
oh, we're recording all this. Lol. Alright.
I'll just stop.
No worries. Yeah,
Anyway,
I
the
was
thing
saying.
is, I can always